Let's get some of our basics on data structures clear in this section. Let's start by understanding what is data structure, where and how to use it. As usual, starting with the definition. Google says data structure is a particular way of organizing data in a computer so that it can be used effectively. For example, we can store a list of items having the same data type using the array data structure. Let me reiterate the definition again. Data structure is a particular way of organizing data in a computer so that it can be used effectively. Let's spend some time to understand the definition, because it is really important to get it right. Let us start with the basic question. Why should we organize data in a computer? And why can't it be the same way all the time? For the first question, maybe if you want to retrieve or read data again, you have to store in some order. The second question is more important, but if you think a little bit, it is obvious that data stored or arranged in some order is not always good for everything. For example, we have two ways to get to a topic in a book: 1. Table of content, and 2. Glossary in book. If you urgently want to refer a particular topic, you go to glossary and get the page detail and jump to the place directly. In some other case, you do a full book read. Same analogy can be applied here. Different application needs can be satisfied better if you organize data differently in a computer. Still not convinced? Let us go a bit further. We have been taught that computer always operate data as zeros and ones. In other words, for a computer everything is zeros and ones. Then how computer can play videos, view emails, presentations and so on? Data structure is at the core of all these applications. Let us see this with an example. What is this image? Zeros and ones. Right. Can you interpret anything? Honestly, I cannot interpret anything. How about grouping the zeros and ones by bytes and displaying their hexadecimal values? For your convenience, I have also added comments and organized them. Pause the video and take your time to guess. Maybe someone with assembly programming background could have found it. Otherwise, it is still some unknown chunk of data. No big surprise. It's actually the machine code of the compiled C program that prints, "Hello World." What we have seen is the set of machine code that is being executed sequentially by x86-based computer. To give more clarity, let us see how an integer value, double value, is actually stored and interpreted from zeros and ones. Even these integer, float, double, pointers are also data structure. They are supported in every computer and are called primitive. You could see in the diagram how the first 4 bytes, 32 bits, is combined to store and retrieve our integer value 255 in this case. Similarly, a 16-bit short integer with a value -1. Also, a double and pointer value is shown. I hope I have conveyed what a data structures exactly means, and why it is important for computer programmers to do their job better. Now, let us get to the theory part. Based how the data is organized, data structures are categorized into two: linear and nonlinear. Linear data structure are the set of data structure where the data is organized in sequence one after another. Each one of the individuals differ on how you add, remove and access data from it. For example, stack data structure allows a strict ordering of adding data and removing data. We call it LIFO, last in first out. On the other hand, queue follows a strict ordering of FIFO, first in first out. Unlike linear data structures, elements in nonlinear data structures are not in any sequence. Instead, they are arranged in a hierarchical manner where one element will be connected to one or more elements. Trees and graphs are the best example of nonlinear data structures. There are various special cases of trees and graphs, and we have specialized data structures within them.